Quick question, if you drew an arrow pointing straight up from Earth right through the sun and kept going, where would it actually end up? Most people have never even thought about this because we're all taught the same flat, tidy picture of the solar system. Sun in the middle, planets circling around it on one flat plane, like marbles rolling around a table. Today, I want to show you why that picture is basically a lie and what's actually hiding above and below our solar system. Some of it is genuinely strange. Let's start with speed. Right now, as you're watching this, you're moving at roughly 515,000 miles per hour. That's how fast our entire solar system is being dragged around the center of the Milky Way. And even at that insane speed, it takes about 230 million years to complete a single lap around our galaxy. Think about what that means. The last time our solar system was sitting in this exact spot in the Milky Way, dinosaurs hadn't even shown up on Earth yet. They were still tens of millions of years away from existing. Dinosaurs then rose, ruled the planet for well over 100 million years, and got wiped out by an asteroid, all while we were still on the same lap around the galaxy. Only after all of that did mammals evolve, then primates, then humans, then agriculture, then the invention of the telescope. And with that telescope, we started drawing those tidy little diagrams I mentioned. Sun in the middle, planets lined up on flat circles around it, clean, simple, and mostly wrong. Here's the truth. Almost nothing in the solar system actually orbits on that flat plane, which astronomers call the ecliptic. Mars is off by about 2 degrees. Mercury is tilted almost 7 degrees. Pluto, remember when it was still called the 9th planet, has an orbit tilted a whopping 17 degrees from the plane the rest of the planets roughly share. Once you get to asteroids and comets, the numbers go from slightly tilted to what is even happening. The near-Earth asteroid known as 3200 Phaethon has an orbital tilt of about 22 degrees. And Halley's Comet, yes, that Halley's Comet is inclined by more than 162 degrees, which basically means it loops around the sun in the opposite direction from everything else. So the solar system isn't a flat disk at all. It's a three-dimensional, tilted, chaotic mess of orbits stacked in every direction, which raises an obvious question. If it's not flat, what's actually above it? What's below it? And is there anything hiding up there or down there that we still don't understand? That's exactly what we're diving into today. I'm your host. Let's get into it. On Earth, up and down are easy concepts. Your feet are on the ground, the sky is over your head, and gravity constantly pulls you toward the planet's center. Simple. Out in the vastness of space, there's no ground and no sky. There's no built-in north, south, east, or west either. If you want to talk about up or down out there, you have to pick a reference plane and stick with it. For the solar system, that reference is the ecliptic, the average plane the major planets roughly orbit around. Mercury, with its roughly 7-degree tilt, spends part of its orbit above that plane and part of it below, tracing out a slow, tilted loop through space. Zoom out to the scale of the entire Milky Way and you need a much bigger reference, the galactic plane. It's essentially the same idea as the ecliptic, just stretched across 100,000 light years instead of a few hundred million miles. Draw a line straight up from that plane, 90 degrees, and you land on an imaginary point astronomers call the galactic North Pole, mathematically placed in the direction of the constellation Coma Berenices. Draw the same line downward and you get the galactic South Pole pointing toward the constellation Sculptor. You might be wondering, if space genuinely has no up or down, how did we decide which pole is north and which is south? The answer: in 1959, the International Astronomical Union formally defined the galactic coordinate system, and they deliberately oriented it so galactic north lines up roughly with Earth's own north celestial pole. Once that decision was made, astronomers could define galactic latitude and longitude the same way we use latitude and longitude here on Earth. Now let's zoom back into our own solar system, because there's more hiding here than you'd think. Over billions of years, countless asteroids have smashed into each other, comets have been torn apart, and even entire moons and planets have collided in the distant past. All of that violence scattered an enormous amount of dust throughout the inner solar system, forming a faint cloud that isn't confined to the ecliptic plane at all. It spreads above and below it too. Astronomers call this the zodiacal dust cloud. This dust is mostly concentrated in the inner solar system because past that point, gravity giants like Jupiter, Saturn, Uranus, and Neptune have already vacuumed up most of the loose material. Some of it now sits frozen in their rings. Beyond that lies the Kuiper belt, a region roughly 30 to 50 astronomical units from the sun. Quick refresher for anyone who needs it. 1 astronomical unit is the average Earth to sun distance, about 93 million miles. This is where the flat solar system system idea really starts to fall apart, because objects like Pluto and dwarf planets like Haumea and Makemake all orbit on steeply tilted paths, proof that the outer solar system is far messier than the neat diagrams suggest. Push out even further to about 30 to 100 astronomical units, and you enter the scattered disk home to what astronomers call trans-Neptunian objects. These are objects that, over the solar system's history, have had their orbits violently reshaped by Neptune's gravity. Some of them, like Eris and the object 2004 XR190, have orbital tilts exceeding 45 degrees. And here's a fun one. Many scientists believe the hypothetical Planet 9, the biggest unsolved mystery in our solar system, might live out here in the scattered disk too. To be clear, that's still just a hypothesis. Nobody has directly found it yet. Past the scattered disk lies the most mysterious region of all, the Oort cloud. Astronomers believe it's a colossal spherical shell made of trillions of icy bodies, completely surrounding our solar system, potentially stretching anywhere from 20,000 to 200,000 astronomical units from the sun. That works out to roughly 3.2 light years. And here's the wild part. We've never actually seen it directly. Its existence is inferred purely from the behavior of certain long-period comets, like Comet C/2013 A1 and Comet C/1975 V1, which take hundreds of thousands of years to complete a single orbit and swing in from extreme angles relative to the ecliptic. Based on those extreme tilts, scientists believe the Oort cloud must extend in every direction, above the ecliptic, below it, all around it, packed with trillions of icy objects we'll almost certainly never learn anything about, because most of them will never travel anywhere near the inner solar system. Now let's talk about what's happening directly above the sun's north pole, because it's not empty up there either. It's absolutely saturated with magnetic fields and charged particles. The sun doesn't just emit light, it constantly blasts out solar wind, and that wind is strongest near the poles. Picture a river flowing outward from its source until it eventually reaches every corner of the land around it. That's basically what's happening here, except the river is streams of plasma pouring out from the sun's poles, and over billions of years, those streams have inflated a massive protective bubble around the entire solar system called the heliosphere. In plain terms, the heliosphere is the boundary out to which the sun's influence through solar wind actually reaches. Beyond it lies true interstellar space. Solar wind travels at roughly 250 to 500 miles per second, which is exactly why the heliosphere manages to balloon out to billions of miles across. The point where the heliosphere and interstellar space physically collide is called the heliopause. On August 25th, 2012, Voyager 1 became the first human-made object to cross it, exiting above the ecliptic plane. Voyager 2 followed in 2018, crossing the heliopause from below the plane. Now that you understand the heliosphere, picture the whole solar system as a giant bubble drifting through the galaxy. As it drifts, it passes through different interstellar clouds along the way. Right now, we're inside one called the local interstellar cloud. And at our current speed, we won't fully exit it for a very long time. It's about 30 light years across. That cloud itself sits inside something even bigger, the local bubble, a cavity roughly 1,000 light years wide. The leading theory is that a chain of ancient supernova explosions blew the surrounding gas and dust outward, hollowing out this enormous, mostly empty cavity, though a few smaller clouds, including the one we're currently passing through, still drift inside it. Matter inside the local bubble is about 10 times less dense than the galactic average. Instead of thick clouds of hydrogen, there's a nearly empty void filled with extremely hot, thin plasma, reaching temperatures around 1 million Kelvin. At the bubble's outer edges sit invisible walls, regions where interstellar gas has been compressed by the pressure of ancient supernova shockwaves. These walls interact with neighboring structures like Loop 1 and the North Galactic Spur, both of which show up as giant arcs in radio and X-ray wavelengths, completely invisible to the naked eye, but absolutely fascinating once you know they're there. And speaking of fascinating, let's talk about one of the strangest discoveries in modern astronomy, the Fermi bubbles. Discovered in 2010 using NASA's Fermi Gamma Ray Space Telescope, these are two enormous balloon-shaped structures extending roughly 25,000 light years above and below the supermassive black hole at the center of our galaxy, Sagittarius, a star. They're so energetic that if human eyes could see gamma rays, the Fermi bubbles would be the single brightest, largest structures in the entire night sky. Astronomers still aren't sure exactly how they formed. Leading theories point to either a massive burst of star formation or an ancient eruption from the galaxy's central black hole. Whatever caused them, they prove something important. The energy at the heart of our galaxy doesn't stay confined to the galactic plane. It punches straight through, above and below. And finally, there's one more thing surrounding the solar system, above it, below it, everywhere, that we've known about for decades but still haven't directly detected. Dark matter. It emits no light, reflects no light, and yet it's believed to make up roughly 85% of all the matter in the universe. Scientists think of it as an invisible scaffolding that gives galaxies their shape and holds them together. Without it, a galaxy like the Milky Way would likely fly apart from its own spin. Astronomers believe our solar system is currently moving through a strand of this dark matter, one that extends above and below the galactic plane, just like everything else we've talked about today. We still haven't caught it directly, but particle detectors and telescopes around the world are actively hunting for it right now, and it's entirely possible that this single mystery could end up unlocking some of the biggest secrets in the universe. So, here's a question for you. What else do you think might be hiding above or below us, waiting to be discovered? Drop your best theory in the comments. I want to hear it. If you enjoyed this one, hit like, share it with a friend who's into space, and subscribe with notifications on so you don't miss the next episode. See you in a black hole.